We continue now with a conference on international policies on the exploration of space. The program included remarks by scientist Carl Sagan, the president of the Planetary Society.
Our keynote speaker for the afternoon is indeed Carl Sagan, David Duncan Professor of Astronomy at Cornell University, an active planetary scientist, in addition to being a world figure with an agenda that's as broad as the concerns that push humanity. Interesting change in Carl's proposed talk that happened in the last week, and I'm interested to see how it will affect his remarks. The title that went out on the preliminary announcement of this program, I think most of you will remember, said, "What Mars Can Do for America." The title that Carl is going to speak to this afternoon is somewhat broader, "What Space Can Do for America." Carl Sagan.
Thank you, John. Well, I changed it from Mars to space when I realized that the audience would be rather different from the one at our meeting the last few days, and I wanted to be able to represent at least a range of opinions expressed at our meeting. And it is also true that the title says what it can do for America, but as you will see, I will try to broaden that focus as well. Imagine yourself as a kind of extraterrestrial observer watching the Earth over the last 4.6 billion years since its formation. At the beginning, especially, you see a lot of things falling into the Earth, the final stages of accretion. But you see hardly anything leaving it, an occasional hydrogen atom. That's about it. Maybe a big impact sprays debris off the Earth. For 4.6 billion years, it's one-way traffic. And then, suddenly, just in the last few decades, in our time, that situation changes. Suddenly, there are little objects filled with instruments leaving the Earth, orbiting it, entering into orbit about the Sun as artificial planets, and then running through the solar system. Little elegant space probes examining every one of the planets known to the ancients, from Mercury to Saturn and beyond, Uranus, and next August, Neptune. And not just instruments, but occasionally people also. Mostly they hug low Earth orbit, cannot bear to leave the mother planet, so it would seem, but 12 of them go as far as the Earth's natural satellite, the Moon. This is an extraordinary event. It is an historic event. It is the first tentative stepping out into a vast cosmic environment. And in the long historical perspective, provided we're not so foolish as to destroy ourselves, I think these events will be as significant as when our ancestors came down from the trees about 10 million years ago, and when our still more distant ancestors crawled up on the land about 500 million years ago. We are entering a new environment far vaster and more promising than the savannas of East Africa or the previously untenanted land. So in the broad picture, I think that's the large-scale significance of space. But on the other hand, there are all sorts of shorter-term issues, and I would like to address some of the practical benefits of space. By practical, I don't just mean making money, but also issues having to do with the human spirit, the human heart, and necessarily political issues. First, let me say that I endorse Lyndon Johnson's assessment that military reconnaissance satellites by themselves justify the entire cost of the space program, and I would say that that is true for the Soviet Union as well as for the United States. Reconnaissance and treaty verification satellites are essential. They calm the hotheads and paranoids on both sides, who otherwise would be making prudent worst-case judgments, which then drives the arms race. And especially as we are entering into a remarkable new era, apparently, of significant, perhaps even massive arms reductions, such satellites are even more important. On the non-military side, it is clear that communication satellites, for example, are a self-supporting, extremely profitable, extremely useful industry. If you, never mind in the United States, suppose you live on an island republic like Indonesia, where there are thousands of separate islands. The laying of submarine cables from island to island is vastly expensive. If you have a geosynchronous communication satellite sitting above your nation, you can talk from island to island at much less cost, much higher efficiency. The world is now bound up via communication satellites. And this has not just a practical utility for businessmen and emigres, but also a long-term practical consequence of binding up the world, of breaking down the barriers between peoples, of bringing us all together, something extremely important, in fact, desperately needed. The availability of direct long-distance dialing to and from the Soviet Union, I think, is a very useful figure of merit about the degree of openness in Soviet society. It was tried experimentally for a few months and some years ago, pre-Gorbachev, and then dropped for reasons we might speculate on. I think a very important gesture on part of the Soviet government would be to open up the Soviet telephone system both ways to world communications traffic. Meteorological satellites are extremely practical. These days we're quite used to looking at the evening television news and seeing a picture from a geosynchronous satellite showing clouds moving somehow not continuously. And in the practical value of alerting farmers about disastrous storms and temperature decreases, these are again extremely cost effective. And there are some other things along these lines we might mention, but I think this is a comprehensive enough list on the very straightforward practical side to see that space flight is an extremely important aspect of modern life. Beyond this, there is the scientific and exploratory function of the space programs of many nations. If you step back and just think about it, it's astonishing that real money has been spent by governments on astronomy from space, on sending spacecraft to other worlds. A lot of money has been spent on that. There's no immediate practical benefit. I will try to indicate a little later that the slightly longer-term practical benefits are very significant. But basically, this was supported in order to encourage the increase of knowledge. And I think the spacefaring nations should be commended for that. The United States, the Soviet Union, ESA, Japan, and fractionally a few others. I'd like now to turn more specifically to the NASA program and start with what I think is the key, the fundament of the history of NASA, and that is the Apollo program. NASA was started before Apollo, just a little bit before Apollo. It was formed in part as a response to the successful Soviet launch of Sputnik 1, but the formulation of the Apollo program was a specific response to the orbital flight of Yuri Gagarin, the first human to orbit the Earth. And this was not just a propaganda battle. The orbital flight of Yuri Gagarin indicated a very significant Soviet booster capability, lift capability, and must be understood in the context of the strategic nuclear confrontation between the United States and the Soviet Union. The flight of Gagarin and Herman Titov and their successors in precise orbits, their successful recovery, clearly indicated that the Soviet Union had a capability to deliver nuclear weapons halfway across the planet by strategic missiles. And this was considered to be very worrisome in the United States, not just for the obvious point that the United States could be annihilated. The Soviet Union could also be annihilated at that time by a much larger U.S. bomber force, but also because of the sense of diminished American self-confidence and concern about American allies looking eastward. The Apollo program must be understood in that context, and you can see it in President Kennedy's famous speech announcing the Apollo program. He did not advocate a return of a sample from Mare Tranquillitatis. He did not advocate determining the origin of the moon by the end of the decade. There was no science whatever in his announcement. What he said is that the program would put an American on the moon by the end of the decade and return him safely. President Kennedy's science advisor, Jerome Wiesner, had a deal with President Kennedy that if the president did not describe Apollo as scientific, Wiesner would support it. And that is, with a couple of exceptions, what happened. Apollo was a political program. Another way to see that is to look at the last Apollo mission, Apollo 17, which flew, I think, in 1974. On Apollo 17, the second guy to climb down the ladder was the last man, the last human to set foot on the moon. He was also the first scientist to set foot on the moon. Jack Schmitt, former U.S. Senator from New Mexico. As soon as a scientist set foot on the moon, it was clear that the program had gone too far. And it was promptly canceled as redundant. Apollo was not a scientific program. I think it's very important to remember that programs of that magnitude are driven by political, not scientific reasons, and that is even more true today when there's a lot less spare cash around than there was in the early 60s. Nevertheless, under the Apollo aegis, a great golden age of scientific space exploration occurred. And I don't know if this is going to work. I hate to ask for the Planetary Society's flag to be removed, but I would like to show a few slides. I also would appreciate if the lights could go down. Thanks. Oh, maybe this is going to work. Well, what I hope to describe to you is the timing of the major missions of the U.S. planetary program. Good, the lights now seem to be in good shape. Now all we need, this is a well-known, mass-produced, highly reliable Kodak technology. Now, can we do anything about the backstage light? I'm just trying to think of something to do. Thank you. Okay, now I really have run out of small talk. Oh, that's good. That'll take me a minute. Pose an intellectual test for the speaker, too. That's terrific, but that's not the slide. If I could have the one before that, please. Ah, great. Thank you very much. Okay, this does slip slightly off the edge, but why don't we have the left-hand margin and let the right-hand margin fend for itself? Thanks. Okay, so these are the decades of the U.S. space program, 60s, 70s, 80s. And here you can see in yellow the Mariner missions, Mariner 2 to Venus, first spacecraft to orbit another planet, the mission which gave what I consider the definitive first evidence that the high radio temperature was coming from the surface of Venus, and that led to confirmation that it was a massive greenhouse effect. Mariner 4, first spacecraft to Mars, 5 to Venus, 6 and 7 to Mars, 9, the first spacecraft to orbit Mars, 10 to Venus and to Mercury. Here in white are the robotic precursors to the Apollo missions, the Rangers, lunar orbiters, and surveyors. And then here are the Apollos. Apollo 11, first spacecraft to carry humans to another world, through Apollo 17 in 1973, not 74. Moving target. Also, we can see Pioneer 10 and 11, appropriately named spacecraft, the first to leave the inner solar system and fly by Jupiter and Saturn. The phenomenally successful Viking spacecraft, 2 orbiters, 2 landers, first spacecraft to successfully land on Mars. The Voyager spacecraft, which are still functioning and very well, that have given us our first close-up reconnaissance of Jupiter, Saturn, Uranus, and shortly Neptune, and their rings and their satellite systems some 40 worlds, more, 45, have been explored by Voyagers, and then Pioneers 12 and 13 to Venus, first American spacecraft to land on Venus. Now this is a spectacular record of accomplishment for a tiny fraction of the NASA budget, as you'll see shortly, except for the Apollos. Apollos cost a lot. The rest of it costs very little, and that is a reminder to us that other things being equal, robotic spacecraft cost tens of times less than a comparable manned mission. Well, we see this big cluster of spacecraft here and here, all done under the aegis of the Apollo program, and a few that come after, Viking, Voyagers, Pioneer 12 and 13. Next slide, please. No, but before you go to the next slide, I beg your pardon. Can we go back? Okay. The arrow of time is unidirectional. You probably noticed that the decade of the 1980s did not have a single multicolored triangle in it. We have now finished an entire decade in which the United States has not launched a single spacecraft to the moon or the planets. 10 years after this golden age of planetary exploration, 10 years without a single spacecraft being launched. And this is not just due, it's not primarily due to the Challenger tragedy, because it began long before. The United States has opted out of planetary exploration. Here is the study approval and launch dates of the 3 spacecraft missions that followed Apollo 17, and you can see that the approval dates for Viking and Voyager were still in the midst of the Apollo missions, and Pioneer Venus just after. So while we could argue that the fascination with SDI has deflected some intellectual, fiscal, and presidential attention resources away from the civilian space program, I think the main reason that this decline in U.S. planetary exploration has occurred is because Apollo simply ceased. Next slide. Here is the planetary exploration budget in percent of federal budget, and the highest number here is 0.25%, so of course it's a tiny fraction of that. As a function of time, here's the big Apollo peak, and here is a subsidiary peak due solely to Viking, and it has been at this constant low level ever since. And the next slide. Now here are in constant, I can't read what year it is, constant 1980 something dollars, as a function of fiscal year, 1982, thanks. And the total NASA budget is here in vivid puce, or whatever this is. And the OSSA, Office of Space Science and Applications budget, seen here in orange, multiplied by a factor of 10. So we can do the comparison. This is the Viking bump. And notice how closely the space science curve tracks the total NASA funding curve. So I think a realistic case can be made that the grand exploratory missions go up when the total NASA budget goes up, and down when the total NASA budget goes down, or put another way, that a grand long-term objective that involves exploration is the umbrella or aegis under which these other missions can be accomplished. Can I have the lights, please? Overhead lights, I mean. Thank you. So now NASA is in a rather different circumstance. It has just emerged from the Challenger disaster. I think it is not unfair to say that at least significant segments of NASA have been in a discouraged mood, distracted, uncoordinated, in some cases incoherent. The American space program has been on hold. The great exploratory ventures out into the universe have virtually ceased, and it is a very important question to ask what could be done to resuscitate NASA. NASA has not had a coherent goal since the end of the Apollo program, and it certainly has not had a long-term goal deriving from a coherent statement of presidential interest since the end of the Apollo program. And therefore NASA has been left to design its own justification. And when any bureaucracy is left to do that, it does what all bureaucracies do. It attempts to preserve the jobs of everybody who's employed at that particular moment, and you get a very interesting pastiche of unrelated programs. I would like now to address the issue of what the American space program should do. What should a coherent long-term goal embracing presidential interest be about? I think I should say just a couple of words on SDI. If I don't, you will see a glaring hole in my presentation. Needless to say, what I am about to say about SDI, as the rest of my talk, represents only my own views, does not represent George Washington University or the Planetary Society or any other organization. I think the original population defense formulation of SDI is a tragic, ruinously expensive mistake, and one, if actually converted into hardware, would significantly decrease the national security of the United States. I'm prepared to defend that. I've done it on a number of occasions. I've debated in 3 public forums with General Abramson. I recognize that's not the function of this discussion, but just wanted you to know where I stood. Let's now return to the civilian space program and talk about what the overarching kind of goals should be. I see 2 principal such goals. They are neatly compatible. And they have a number of other connections as well. The first one I want to talk about is something that's been very nicely described as mission to planet Earth. That is, a study of the Earth from space from the same global perspective as these other planetary missions have done for other planets. And this has a great head of steam in our discussions in the last 2 days. While there were differences of opinion on a lot of issues, I didn't hear a single negative remark about that kind of goal for NASA, and there's a very good reason for it, and that is that as the human population has grown, as our technological capabilities have also grown, we have amazingly come to the point where we are able to make significant changes in the physical environment of our planet, I mean globally, worldwide, by accident. There are a number of cases of these, and let me just briefly mention 3 of them. The increasing greenhouse effect, the depletion of the ozone layer, and nuclear winter. I'll just say a word about each of them. First of all, because the first two can be addressed in a very important way by such a mission to planet Earth. And secondly, because I believe there's a very neat connection between the discovery of those global dangers and the exploration of other planets. I want to put in the plug for that connection. So I'd like to now show a few of the slides. I borrowed these from Professor Dutton. I'd like to thank him for lending me those slides. First has to do with the greenhouse effect. Wait, let me say something generally first. I'm sorry to be so hard on whoever's controlling the lights. Could I have the lights back on again? If you imagine the Earth sitting at its distance from the Sun, with the present cloud cover, therefore reflectivity or albedo, you can calculate what the surface temperature ought to be. So much sunlight hits the Earth, it's a certain distance from the Sun, you know what the solar constant is, you know what fraction is absorbed. You can then calculate, it's done in Astronomy 101 all over the world, what the surface temperature ought to be. When you do that, the surface temperature calculates out to be 30 centigrade degrees colder than it actually is. And in fact, the calculation, if it were true, would speak of an Earth in which the surface temperature is far below the freezing point, and we'd all be dead. What's wrong with the calculation? What's wrong with the calculation is the greenhouse effect. The calculation neglects the fact that there is a blanket of air, infrared absorbing, but transparent in the visible part of the spectrum, which surrounds our planet. And that infrared absorbing blanket permits the visible light through to heat up the surface, but absorbs the sunlight, absorbs the infrared radiation as the surface tries to radiate back to space. That is called the greenhouse effect. In an inept analogy with what happens in a florist's greenhouse, which isn't this at all, and we owe our lives to the greenhouse effect. A little greenhouse effect is a good thing. On the other hand, I mentioned before that the planet Venus has a surface temperature of some 750 Kelvin, 900 Fahrenheit about, and that is due to a massive carbon dioxide greenhouse effect. Nobody, by the way, proposes that there were a bunch of beings on Venus who went too much into the automotive industry, and that's the reason. But Venus is a very important object lesson in case anybody thought, well, nothing to worry about greenhouse effects. There's a very good case. Now, if I may have the next slide, and thank you. So here is a set of observations made from 1958 to almost the present, a ground-based observing station in Hawaii. You can see the annual variation in carbon dioxide having to do with the seasonal taking up of CO2 by plants. But the net trend is very clear and a monotonic increase in the CO2 abundance. And the same is true, and even steeper, with the abundance of methane, another greenhouse gas. The increase in these molecules means that there is an increasing greenhouse effect, which ought to result in an increasing average global surface temperature. Next slide. Here we can see the increase in the world's population from 1850 to the present, and there's been an absolutely spectacular exponential growth in the Earth's population, and the carbon dioxide increase parallels the industrial growth of the Earth. Next slide. Here is a set of measurements of the global average surface temperature, and this comes about not because anybody was in Earth orbit examining the whole Earth, but by putting together with appropriate weighting the measurements from various ground stations, a much less reliable method. Nevertheless, there is a trend which seems to be quite clear. According to James Hansen of NASA's Goddard Institute of Space Sciences in New York. The decade of the 1980s has already had the three hottest years in the last 150, and if the trends continue, he says 1990 will be on global average the hottest year in the last 120,000 years. That's something worth paying attention to. Next slide is just a neat graphic reminder of the mechanism of the greenhouse effect, which I talked about before. The infrared active gases, they don't sit in a layer up there, they're distributed through the troposphere. Visible light through, they absorb infrared radiation, heat the surface of the Earth. So what? What's a few degrees increase in temperature? Nobody can do reliable prognostications of the local weather from this cause, but there are a number of models, both the general circulation models and analogies with paleoclimates in which the carbon dioxide abundance was higher. And while these models cannot be believed in regional detail, something like what they say is very probable. Some of the models, for example, predict well, all of them do, something like a 3 to 5 degrees centigrade temperature increase by the middle of the next century, which is enough in some models to convert the American Midwest into something approaching scrub desert. The melting of glacial and polar ice is raising sea level so that a few feet rise can be anticipated in this period of time, and if the trends continue sometime in the century after, we may have the collapse of the West Antarctic ice sheet and the inundation of every coastal city on the planet. This is serious stuff. Next slide is a schematic about the ozonosphere depletion. A bunch of chemists in the 1930s are given the job of designing a perfectly inert, safe material to act as a refrigerant in refrigerators and for other functions. They come up with them. It's given the DuPont brand name of Freons, specifically designed to be free. Nobody figured that their very inertness would save them from chemistry near the surface of the Earth, so that when they reach the ozone layer, they would interact with a highly chemically reactive ozone, begin depleting the ozone layer, increasing the flux of ultraviolet light through the ozone layer. Its thickness, if brought to standard temperature and pressure, is only a few millimeters, and an increase in ultraviolet light at the surface of the Earth is dangerous in many different respects, increasing skin cancer for whites only, by the way, but there's a fair number of whites on the planet, and but that's not nearly as serious as the effect of sublethal doses of highly sublethal doses of ultraviolet light compromising the immune system, and the propagating consequences of killing one-celled plants that are at the base of a vast food pyramid at the top of which sit we. Lights, please. This is another extremely serious environmental hazard produced by human activity that we have only recently discovered. Overhead lights, please. And then the third, which I just want to spend a moment on, is nuclear winter, the discovery 38 years after the invention of nuclear weapons, that the explosion of nuclear weapons over, and put it a different way, even a small nuclear war can, through the burning of cities, produce a global climatic catastrophe of considerably more than 10 degrees centigrade temperature decline over the northern hemisphere. And I should say that all the recent models of nuclear winter have converged on the same answer. Now, it would be foolish for us inhabitants of the Earth, but also us Americans, to ignore these very clear signs that the global environment on which we depend is in danger. It's essential for us to understand the nature of the danger, to figure out what we can do to ameliorate or prevent, and beyond that, to try to seek out and diffuse those other environmental dangers that we so far have been too ignorant to detect. There must be others that we haven't figured out yet. And that's one of the places where the convergence between planetary exploration and preserving the Earth comes. Because take a look at the greenhouse problem. I've already said the value of Venus in convincing skeptics that there really is a greenhouse problem. But beyond that, I'd like to call attention to the training of some of the scientists who've played key roles in these discoveries. One of the most important models of the greenhouse warming is due to Jim Hansen and his colleagues at the Goddard Institute of Space Sciences in New York. I already alluded to some of their work. That's already a connection, but the connection goes much deeper. Where did Dr. Hansen develop his interest and expertise on greenhouse effects? His doctoral thesis was an attempt to disprove the greenhouse effect as the source of the high surface temperature of Venus. He cut his teeth on a planetary global greenhouse problem and then applied it to the Earth. Take the ozonosphere depletion problem. This was done by Rowland and Molina at University of California, Irvine. By the way, it wasn't done by the Environmental Protection Agency protecting us. It wasn't done by the Department of Defense defending us. It was done by two ivory tower scientists at the University of California, Irvine, and is an important reminder of why the nation should spend money on basic research. Rowland and Molina used a absolute reaction rate kinetics scheme to figure out what the result would be of the chlorofluorocarbons in the ozonosphere. To do that, you need to know reaction rate constants. They have to be measured in various laboratories. If you look at those reaction rates, you discover that a significant number of the reaction rates used were derived from laboratory work supported by NASA. Why did NASA support it? Not because of interest in the Earth, but because there are halogen compounds in the atmosphere of Venus. So by this surprising indirect route, NASA played an important role in the discovery of the danger to the Earth's ozonosphere. The second group that confirmed the Rowland Molina findings was a group under Mike McElroy at Harvard. They had a whole computer program set up ready to go so they could check Rowland Molina as soon as they heard of it. Why did they have that program all set up and ready to go? Because they were working on the photochemistry of the atmosphere of Venus. It's relevant to the Earth to study Venus. By the way, Mars, which has no ozone, or no significant ozone, permits the full flux of ultraviolet light to reach the surface of the planet, and this may very well have something to do with the fact that in the surface layers to which we have so far dug, there is not only not a hint of life, but you can't find a single organic molecule. That region is being fried by ultraviolet light. And then the final case, nuclear winter, there were 5 of us who did the first calculations of the nature and magnitude of this consequence of nuclear war. 3 of us were full-time planetary scientists. 2 of us spent some fraction of our careers in planetary science. The computer used was a NASA computer. There's a very clear connection, and the connections go much further. Our first interest in what the global climatic consequences of putting a haze of fine particles up in the atmosphere would be came from work connected with the Mariner 9 mission to Mars. So, there are two things that come out of these remarks. The first, that NASA, but the government in general, needs to devote a very serious program of Earth satellites to monitoring the global environment, looking for items that change, and prescribing solutions. And secondly, that planetary exploration, I'm talking robotic vehicles, needs to be supported for this reason alone. If we didn't have an ounce of adventuresome spirit in us, didn't care about the adventure of exploration, for purely practical, everyday reasons, it makes sense to explore the planets. Now I want to go to my last topic, which is the other aspect of what I believe the U.S. space program ought to focus on. There is nothing in robotic exploration of the planets, in great astronomical observatories in Earth orbit, in instruments in Earth orbit monitoring the health of our global environment, that requires people. It is much more cost effective and in some cases much more reliable to use robots than humans. Nevertheless, NASA is strongly oriented towards manned and womaned spaceflight, and as all ongoing bureaucracies, it probably needs a reason to continue flying people. I don't think that in itself is justification for doing it, but I think there is a reason, and I think it's a very powerful reason. It is the complement, the obverse of the Apollo program. The United States and the Soviet Union have now fully demonstrated to everybody on Earth that they are capable of obliterating each other and most of the human species as well. No further demonstration is needed. No politically driven space race makes any more sense, especially in this recent, astonishing Gorbachevian period. What is needed, though, is for the two nations that have booby-trapped the planet with nearly 60,000 nuclear weapons to demonstrate that on a long-term basis they can work together in high technology for the benefit of the human species. There are many ways in which they ought to do that, but the one that has a practical basis, has precedent in the Apollo-Soyuz mission, and has the very real advantage that the head of the Soviet Union has repeatedly called for it, is joint U.S.-Soviet manned and womaned exploration of Mars. And that's what I would like to spend my remaining few minutes on. I believe that a long-term goal of this sort, in which the two countries at first gingerly, with proper concern for technology transfer and the possible unreliability of the other partner, test out a new relationship in all the preparatory space science needed for sending humans to Mars. I think as confidence grows, the effect would be very significant. There is in the psychological literature a range of studies showing that if you, well, let me mention the classic experiment which was done in the 1940s by Muzaffar Sharif, in which healthy, well-adjusted adolescent and sub-adolescent boys were brought to a summer camp, divided into two groups, the Eagles and the Rattlers, I think they decided to call themselves. Everything was very friendly. They then started playing competitive games, two sides against each other, and there then got to be lots of dissension. I'd like to mention, quote just a couple of sentences from there. The tournament started in a spirit of good sportsmanship, but as it progressed, good feelings soon evaporated. The members of each group began to call their rivals stinkers, sneaks, cheaters. They refused to do anything more, have anything more to do with individuals in the opposing group. Secret hoards of green apples were piled up. The rattlers seized the Eagle's flag. One group deposed its leader because he was insufficiently aggressive. And attempts by the counselors to reconcile were unavailing. Then there was introduced a set of common problems which could only be solved collectively. Fixing the water main and others less significant. In the course of dealing with common problems that affected both groups, the hostilities vanished, and to quote the summary, the possibilities for achieving harmony are greatly enhanced when groups are brought together to work towards common ends. Then favorable information about a disliked group is seen in a new light, and leaders are in a position to take bolder steps towards cooperation. The same point was made by Sigmund Freud in his famous 1939 correspondence with Albert Einstein, published in the book called Why War. Freud says the following: anything that creates emotional ties between human beings must inevitably counteract war. Everything that leads to important shared action creates such common feelings. On them the structure of human society, in good measure, rests. Under the aegis of a declared Mars goal, a great deal would start falling into place in NASA. Manned spaceflight, long-duration spaceflight, space station, big boosters, staging in Earth orbit, solar physics, because you have to worry about solar flares on the way to Mars, and of course robotic exploration of the planets. Without such a superordinate goal, I maintain that a lot of that does not make much sense and is likely to be poorly supported in a time when there are so many other urgent claims on the available federal budget. Now, the Soviet Union is in rather good shape for sending people to Mars eventually. They hold by a large factor the long-duration microgravity record, long-duration spaceflight. It's likely to be a year with the current Mir crew. They have the Energia booster, which is Apollo Saturn V class. The United States foolishly threw it away, our own Saturn Vs. They have a very ambitious Mars robotic program, and beyond that they have the repeated clear endorsement by President Gorbachev in favor of a joint U.S.-Soviet human mission to Mars. I think it's rather clear that eventually the Soviets will go with us or without us. I also think it's clear that if the United States does not wish to join the Soviets, and as I'll say in a moment, if it does as well, that other nations, Europe, Japan, perhaps China, perhaps India, will join them. It's not a question of if we don't join, it won't happen. It's a question of it's going to happen. The human species is on the time scale of some decades going to go to Mars, and is the United States going to be involved? I maintain that there is no good justification for us spending badly needed funds on a human mission to Mars other than the political goal of international cooperation with specific attention to improving relations on a long-term basis with the Soviet Union. Various Democratic candidates made strong appeals in this direction, including, to the surprise of some, Jesse Jackson. It is in resounding language in the Republican Party platform. I'll quote the sentence: "We must commit to a manned flight to Mars around the year 2000 and to continue exploration of the moon." I know that most party platforms with a quarter will get you a cup of coffee, so I don't know what weight to give this, but I am told that this is intended seriously by the Republican Party. In addition, there are a number of other congressional senses of the Congress, bills that will be reintroduced in the next 101st session. There is the Mars Declaration of the Planetary Society, in which a remarkably ecumenical group of American leaders has endorsed such a goal, and there are a number of opinion polls which show that the bulk of the American people would be in favor of such a goal. It is, therefore, I claim, politically feasible, and it would do wonders for NASA. I think it is essential that this set of missions, if it comes to pass, be done not just bilaterally between the United States and the Soviet Union, but multilaterally, involving many other nations who have a great deal to contribute financially in terms of intellectual, scientific ability, engineering, and also to play a nice moderating role between the two superpowers. It would clearly be step by step. We would be doing experiments in long-duration spaceflight, in shielding, in staging, in robotic exploration, as I said before, testing each other out. Finally, let me say just a final word about Mars. I had intended to show some slides of Mars, but I've been yammering on too long, so I will not. Mars is a world of wonders. It is vastly more interesting than the moon, I claim, both in scientific terms and in public wisdom. It is a dynamic planet with an atmosphere, with seasonally changing ice caps, with the possibility, by no means certain, of past or present life, with signs of past climatic change, which is something we ought to understand. We who are pushing and pulling with our own environment ought to understand how Mars once had running water, abundant rivers, warmer temperatures, and today is in a deeper ice age environment. The surface area of Mars equals the land area of the Earth. It will occupy us for a long time. Mars delivers. It is not a boring place. There are enigmatic landforms. There are great volcanic eminences, one of them 3 times the height of Mount Everest, a remarkable polar terrain. There's lots of terrific science: geology, meteorology, seismometry, possibly biology. Keep scientists happy. But I stress, you could do all of that with robots. The reason for sending people there has to be political. So in my mind's eye, I see sometime in the next century, one or more great interplanetary transfer vehicles constructed in Earth orbit daily, if we want it, before the eyes of the world's television cameras on the nightly news every night. Cooperative construction by many nations, the completion of journey to Mars, injection into Mars orbit, landing site verification, deboosting from Mars orbit, setting down on the surface of Mars, the first landing on another planet by the human species. There are some who are worried about which nation will first step on the surface of Mars. My solution is you bind the ankles together of the American and Soviet commanders and have them hop out on the 0.38 gravity world. They'll gently settle down, and nobody will be first. Imagine now what I think would be hard to beat in capturing the imagination of people all over the world: a roving vehicle with Americans and Soviets and others in it, wandering across the Martian landscape, going to the exotic terrains that we could never land in Viking, wandering down one of those ancient river valleys, looking for stratification in the banks, looking for the geological record, trying to understand the changes in the environment of that planet, and all of that on the nightly news every night. And then finally the long journey back to Earth. I maintain that that could put space exploration, space activities on the front burner all over the world for a long period of time in the political context of binding up the wounds of the Earth. I think it would be a wonderful thing if the planet named after the god of war could help to increase the peacefulness of the inhabitants of our small and vulnerable world. Thank you very much.
Thank you very much, Carl. We do have about 5 or 10 minutes for questions, if there are any. So there are microphones in the aisles if people have some questions. Are there questions? Joe?
This is a soft question. In addition to supporting international cooperation at the level of going to Mars with the Soviets, are there other lesser projects, such as the International Space University and other initiatives that you would support that might build some bridges to the Soviet Union? And another possibility is some small missions, communication mission for health and medicine that's been discussed with the Soviets. Do you see some possibilities at that level if we don't get the big bucks?
Absolutely, and search and rescue satellites in Earth orbit, and activities across the board. I think it is to the interest of both nations, within reasonable technology transfer constraints, to do as much of that as possible. Soviets have good scientists in a lot of areas. In a lot of areas they have significant space technology experience. They have large budgets, and it's very much in the interest of everybody on this planet for the United States and the Soviet Union to find a range of important joint activities to do.
Dr. Sagan, you didn't mention in your description of NASA activities over the last 2.5 decades anywhere what effect the space shuttle and the research into that has had on it, and I know it's a fairly controversial issue. Could you just mention what your opinion is of that effect and how the space shuttle may be utilized or should possibly not be utilized in further exploration and development of space?
Thank you. It's as you recognize, a long and painful issue. I think the United States made a extremely serious error, the civilian program, more foolish than the military program, in putting all its launch eggs in the single shuttle basket. It means every time you want to launch something, you have to send people up, not just putting them at risk, but making the whole launch business much more expensive. It makes competition and waiting in line for the next available shuttle, when if there were non-reusable launch vehicle fleets that NASA had been using, that wouldn't be the case. And of course there's the the Challenger tragedy. I think the shuttle is an example of a capability without a mission, without a real, unique mission that could not be done otherwise. I mean, the usual justifications are, yes, it's needed in order to put people up into space, but why do you want to put people up into space? Well, we want to study human physiology in Earth orbit. But why do you want to study human physiology in Earth orbit? So we can have longer duration spaceflight by humans. Why do you want to have longer duration spaceflight by humans? And we never get a coherent answer. The kind of answers that one can hear are humans have capabilities that machines don't have. And so when there's an unexpected problem, the humans can solve it and the robots can't. And then there'll be some pointing to, let's say, the Skylab sunscreen, which required an astronaut and a screwdriver to first order. But if anything like the amount of money spent on humans in orbit could be spent on artificial intelligence and a new generation of robots, you could have screwdriver-wielding robots in Earth orbit, or teleoperator-controlled machinery in which the human operator is on the ground and the robot is in orbit, to do that sort of thing. I think sending people up into space started out as political. The political justification then withered, but it remained a constituency that was very powerful in both the United States and the Soviet Union, with considerable inertia of its own. As far as I can see, the only justification for the cost, both in money and in the danger to human lives, of people in space has to be political, or, if you wish to think of it in those terms, historical. But if that's going to really work, we have to understand precisely what is the goal of those humans in space. And I maintain that a goal like the Mars Initiative makes sense out of that otherwise redundant capability. Yes, please.
Dr. Sagan, the idea of a manned mission to Mars is a very exciting one. It's one that captures our imagination. But if such a project were undertaken and successfully brought to conclusion, how would we avoid the trap we found ourselves in when we had the whole world excited about going to the moon? Once we got there and we gathered a few samples and we looked around, public interest fades. It's going to be tremendously expensive, and what's more, we could get missions to the moon pretty quickly and back. We're talking about a substantial period of time getting to Mars and back. How do we sustain the energy and the funding and the resources for something like that?
Thank you. It's a very important question, and I should have gotten to it in my talk. I think the fact that it takes longer to develop the technology and infrastructure to go to Mars is an advantage if you believe in the argument that what we want is a long-term common goal for many nations. If it's too easy, if it's too near, if it's too quick, then we run into the problem that you said. If it's 15 to 25 years away, then I think it has the right reach to prod this continuing collaborative multinational enterprise. It is sometimes said, and I should say there are proponents of going to the moon and not to Mars on those grounds. There are proponents to going to the moon on the grounds that the Russians are going to go to Mars, so we better go somewhere else, which makes no sense whatever in my mind. You could just as well argue the Russians are going into space, so we should stay at home. It is sometimes argued that, well, the moon is a good stepping stone to Mars. It's a good place to practice out Mars roving capability or staging or other things you want to do on Mars. But I point out that low Earth orbit and the surface of the Earth are much better and much safer places to check that out. It's also sometimes objected that the Mars goal doesn't work because it's going to be a stunt, as you sort of suggested. We'll go there once or twice and then it'll end, like Apollo. But I point out that the reason the Apollo program ended is because the United States demonstrated its extremely formidable rocket capability. In fact, the Saturn V booster is far in excess of the military boosters that can reliably deliver nuclear weapons halfway around the world. So you reach a point where you've demonstrated you can annihilate the other nation, and then you don't have to demonstrate that anymore. But you do not reach a point where you've demonstrated that you can cooperate, so you don't have to cooperate anymore. And so I maintain that in terms of political goal, Mars has continuance, which Apollo did not have. Beyond that, Mars is so vastly more interesting in a scientific and adventuresome and exploratory sense than the Moon that I think we land on Mars once or twice and we will find so many fascinating things that Mars will help us to continue.
I'd like to take one more.
Okay.
I think perhaps, Dr. Sagan, you're being too modest, because even in your proposals, I think a political objective is only one objective. But as we think about what we're doing to the planet here, and perhaps in the long run irretrievably or irreversibly, we really have to find other places to live for the human species, and Mars probably isn't very habitable, at least not from a practical point of view, nor is any place else in the solar system. So we have to find some other solar systems and go there. Now, that's a much longer objective, and it probably is an objective of hundreds of years rather than decades. Conceivably, it's unachievable, although I rather doubt it. My own feeling is that it is achievable. And that's a long-term objective for the whole species. Right? You could call it political or social or whatever. But it is a coordinated and cogent long-term objective, and Mars is conspicuously the next step for it.
Thank you. Permit me to disagree a little bit. The Earth is not a disposable planet. It's not if once we mess it up, then we'll go somewhere else. There is, as you properly point out, no other habitat for the human species in the solar system. The excess of births over deaths on the Earth every day is about 200,000. We are not within hailing distance of the lift capability to put 200,000 people every day, even in low Earth orbit, much less to Mars or some other place. Spaceflight is not the answer to solving the demographic problem, and it's not the answer to solving the environmental problem. If I thought things were that critical, I would say we should simply spend our money in making the Earth a better place. And I think that's a good idea in any case. But as I've tried to indicate, I think there are ways in which going to Mars makes the Earth a better place in terms of the relationships of the various quarrelsome nation states. And also observing the Earth from Earth orbit permits us to gain a perspective and understanding of our deteriorating environment, which is essential so we all can survive and prosper on the planet. Thank you.
Thank you, Carl.
Thank you.
Let me ask our panelists to move forward as I introduce their chairman. The idea now is to spend the remaining time both communicating to you in short form the kind of things we've been talking about in our smaller workshop, and then hopefully engage you in some give and take with the members of the panel on the insights and conclusions that we didn't reach that you think should be part of a deliberation. So can I ask all the panel to come forward? As I do, this is doing things in real time, and this is the sort of thing those of you that are in the space business will recognize as draconic. I have not warned any of these people, but we have no overhead projector. And so you can't use view graphs. And we're not set up just the way the panel is to show slides because you're in front of the screen. So you got to depend on rhetoric. There's enough rhetoric in these 6 gentlemen, I think, to suffice, though. The chairman of the panel, Bruce Murray, professor of planetary sciences at the California Institute of Technology and vice president of the Planetary Society. From 1976 to 1982, Bruce was director of the Jet Propulsion Laboratory. Before that, an active participant, before, during, and since an active participant in planetary exploration. Dr. Murray, floor is yours.
Thank you, John, and it's a good feeling to be trying to focus on the issue of international cooperation in space, and to do so in Washington, D.C., which plays a central role, although not necessarily the dominant role in that regard. And to focus, and the title of this panel is on the prospects for international cooperation. The point, we spent 2 days talking about different facets of this in a group that had both international and U.S. representatives. We have here a collection of people who are going to give some little snapshots of parts of that discussion and perhaps give the flavor of it and discuss it in a way, and we'll have some time for questions afterwards. What I will do as an introduction to this is, in my own way, try to summarize what I thought were the key issues that were sort of cross-cutting. Not saying so-and-so talked about this problem or that, but rather what seemed to be generic, what was kind of flowing out of it. And aiming it at an audience concerned with international cooperation, or at least international relationships, and policy issues. That's been the focus. This is not, despite Carl's enthusiasm and mine and most of us for space in its own right, the thing that brings us together is space as a part of an international set of relationships. And so that's really the focus here. Certainly a key part from the U.S. point of view of the civil program and NASA is the fact that NASA started out as an instrument of national policy. The Apollo program, as Carl described, and we all know, was a key element in U.S.-Soviet competition in that period of time, and most would feel a brilliant response to a set of circumstances that presented themselves. When that job was completed in 1972, no subsequent national priority or objectives were established for NASA. And so what's evolved in that period of time is an agency and a set of enthusiasts and a set of budget support and so forth in the Congress and elsewhere that has diverse goals without any stated objective by the United States government as to what it's supposed to do. Lou Allen made a comment in our meeting which I thought was very, very much the point. He says, NASA is not nearly as valuable to the government as it used to be. And that really underlies a lot of the bureaucratic and administrative problems that emerge. Challenger just exasperated these. So that's a problem that's got to be dealt with or will have mediocre outcomes. The second circumstance is, especially with the Gorbachev change, which is not only opening up and novel, but a choosing space activity as an instrument of Soviet foreign policy, and clearly with the establishing U.S.-Soviet collaboration as a objective in its own right, and picking up Western Europe by default, at least from my point of view, we are not positioned well to respond to that. We don't have policy guidelines, and they're fabricated sort of on a case-by-case basis, so the U.S. responds very sluggishly and slowly, and the Soviets have, in an adversary sense, the initiative and maintain it. So that we have to decide and do something about how do we cope. There's a new thing there, and whatever we decide, independent of what the value judgments about how we ought to do it, we ought to do it. There isn't a policy apparatus. There's sort of an incremental decision-making process which is sluggish and cumbersome and makes us look, from the U.S. point of view, a bit foolish, frankly, in the international scene. We don't seem to know where we're headed. An exasperation is that this creates a tension between the traditional relationships we've had with our Western European allies and we were developing with Japan and the Soviets. And again, we're not real clear at a practical level how we cope with that. Have we got a new set of friends over there, or are these still adversaries in a different way? How do we do a Mars mission? How does Western Europe fit in? Is that part of them or not? So, and the people trying to do this do not have policy guidelines or even attitudes in the structure here to help make those decisions. And so again, we're not doing a very good job. That, I think, is factual. What we should do is a matter of opinion. Third, it cuts a little thing, is the role of the moon is a little, is there an international role for the moon or not? Is it the Antarctic explanation or not? A fourth issue that we spent a lot of time on, and Carl's touched on it too, is I think everybody agrees this mission to planet Earth, the use of space as well as other national assets to understand the changes in the Earth's environment and lead into policy attitudes of what to do about it. That's great. We want to do it. There's probably money for that, and even in restricted budgets. The problem, again, is that we're not organized properly in that case. There is no agency that has that job. There are agencies that have pieces of it. There's certainly in the past has not been a good mechanism for them to work together. And even more difficultly, this is intrinsically an international job. It doesn't do any good simply to observe the Earth from space if one can't get surface and atmospheric ground truth, and that in turn forces you to deal with other countries. Even if we didn't want to on political grounds, on technical grounds we would have to. There is certainly no easy mechanism for that. So we got two structural weaknesses in our structure to deal with this. And then finally, looking further ahead, there are some of the speakers gave the common view now that both Europe and Japan's economies are growing so large that in the world that we're going into, we're not going to be the dominant player. We're going to be a major player, but not the dominant. We have to learn how to do that. But more importantly, we have to learn how to persuade the Japanese and the Europeans to make larger resource contributions to these global projects. And that's a leadership job by us. It's not something we can do ourselves. And again, that's a longer range goal. It's an immediate task, but it's something we need to be thinking about for the future. Well, that was my list of cross-cutting issues. Let me introduce the panel and then turn this over to our first speaker, at the end of which we'll permit some questions from the floor, depending on how our time is running. I'll just go from left to right. Dr. Harlan Smith, who's director of the McDonnell Observatory, cooperated with Dr. Hans Mark, who's the chancellor of the University of Texas and a former deputy head of NASA and Secretary of the Air Force, who talked about the moon as a policy objective for the United States, man-moon missions. Roger Bonnet is the director of scientific programs for the European Space Agency, has been very active in trying to get international collaboration, both at Common Halley and other things, and has played a very important role emphasizing the role of Europe, as well as the rest of the world, in this bilateral changing into multilateral space environment that we're living in. Important, and we appreciate very much his efforts in coming here. The next person, Dr. John Dutton, who is the Dean of Earth and Mineral Sciences at Pennsylvania State University, is an advocate for mission to planet Earth. He doesn't really have to advocate, everybody's kind of agreed, and but he did a good job of doing that, and he will be our first speaker when we start talking. Dr. John McLucas is currently the chairman of the National Advisory Council, has a former secretary of the Air Force, a former key person at ComSat Corporation, has a very broad experience in all elements of space activities, and is been a strong advocate for the international space activities. And then finally, from Canada, the Ministry of State for Science and Technology, Dr. Evans represents another country. Roger represents an aggregation of countries, namely Western Europe and ESA. Evans represents a country that has worked both with the United States and with Canada and, and with Europe, and of course is involved in our shuttle and space station programs as a major player. So that I think that's a valuable perspective in its own right. We're going to then start out with Dr. Dutton on the whatever he wants to say.
The priorities are set today, in this instance, not by the urgency of planet Earth, but by the urgency of my flying schedule. But it gives me an opportunity to say a few things about Earth science, global change. You might reflect in your own education whether or not anybody talked to you about the future of planet Earth. We've talked a lot about the past. It's a traditional part of education, secondary school, high school, in college curricula. But it's not until the last few years that we have started to be seriously concerned about the future of this planet. And I think it's not that the future is in doubt. The planet certainly has a future. The point is that it's going to be different. The world is changing. It's changing before our very eyes. And most importantly, this planet is evolving toward conditions never before experienced in human history. It's moving toward this new, unfamiliar, and perhaps inhospitable state because of us. As a result of human activities. The changes are significant. They're occurring today. Dr. Sagan did a very nice job of explaining to you the elements of the global warming that's coming from greenhouse phenomenon, carbon dioxide, largely a product of the use of fossil fuels, and the problems with the ozone layer. I see a lot of you out there experiencing the ozone problem. You're all hiding from the ultraviolet light. So what do we do? Well, from a scientific standpoint, first of all, we document the extent of global change. We determine the rate at which it's occurring. And we determine what the local manifestations of global change are. This requires a commitment to observation, a commitment to maintaining records, a commitment to processing those records. First of all, it's a commitment to using the data that is available today. We have a great deal of information about the Earth, but in our wisdom, or perhaps our bureaucratic inefficiency, we have tended to place most of that data in write-only memories. We could use it. Second of all, we need to observe the state of the Earth, the evolution. We need to study the interaction between the atmosphere, the oceans, the biosphere, and the ice regimes of the Earth. And a good way to do that is with what's been called Mission to Planet Earth. Mission to Planet Earth involves 4 or more polar orbiting platforms. Present plans are for 2 of those to be built by the United States, 1 by the European Space Agency, 1 by Japan. There's no reason that the Soviet Union, or for that matter other countries, could not contribute polar orbiting satellites to take the detailed snapshot of the Earth that we need. The other part of Mission to Planet, or another part of the Mission to Planet Earth, would be geosynchronous satellites, the kind that produce the weather pictures that Dr. Sagan mentioned. They're in orbit over the equator. They are looking constantly at the Earth. Finally, there are a number of research missions designed to measure a variety of things on the Earth. We have a stream of them in the United States. The European Space Agency has some in mind. Japan is planning some. Some of those will be cooperative. We need to continue with them. Given this database, we need to create computer models of the evolution of the planet, which are similar in spirit to the computer models that are used today to make weather forecasts that are often remarkably accurate at 4 to 5 days in the future. With such models, we can make an attempt to predict what is going to happen to the statistical state of the Earth some decades, perhaps centuries ahead, and with those predictions, we can assess the various alternatives in energy use and energy sources that we might be interested in trying. This clearly is an international endeavor. Mission to Planet Earth, you could say, is a mission with a crew of some 4 billion people. It's a global problem. It's a global study, and it requires a global solution. Scientists the world over are concerned about the Earth, the atmosphere, the ocean, the biology, and the ice. We need all of them, and we need their talents to bring this to make successful progress. These scientists are cooperating now in a variety of studies. The World Climate Research Program, the International Geosphere Biosphere Program, and of course they set precedent for much of this with the International Geophysical Year some 30 years ago. They're talking about cooperating with the International Space Year in 1992. And finally, these space programs do involve all of the Earth, and there's no reason that they shouldn't involve and that we shouldn't take advantage of all of the spacefaring nations. And finally, and maybe it's not the most important reason at all, is that it's going to be expensive enough that we should share costs. Well, nothing is as powerful as an idea whose time has come. Global change is here. The need for the peoples of the earth to respond to it is upon us. We need to understand it. We need to predict it. And we may need to change our own behavior. And I think all of this is indeed an idea whose time has come. Thank you, Mr. Chairman.
Next speaker will be Harlan Smith, and picking up on, I guess, the moon.
Dr. Mark regrets that he can't be with us today. He's over at the Pentagon, in fact, and I feel a bit like the boy replacing the 900-pound gorilla, because not only has he had the jobs that were mentioned of being Secretary of the Air Force and Associate Administrator of NASA, but he's also Chancellor of my university. But anyway, Hans and I see more or less eye to eye on these issues, and in fact, I've had probably a good many more years to think about the particular one I'm going to stress today, so maybe it isn't totally inappropriate that I have this chance to be with you. Carl has asked, and several have asked already in the short time we've been with you, why the moon? I think there's a completely different class of answer that Carl did not touch on, that one of the questioners did. And it goes something like this. There are two possible, radically different scenarios for the human race. One is to stay on the earth as long as the human race shall last. Now that's a possible scenario. I think it's a pre-Copernican one in the sense that, there was a time when the earth was the only material body in the universe. But I really believe that that, in fact, is not the plausible or the probable scenario, assuming civilization lasts. In addition to robotic exploration, I quite agree with Carl, that's the way to do most of the exploration. In addition to that, I think there's no slightest question that the human race is going to migrate out into space. Now, the time scale is not simple. The costs are not small. There will be loss of life. But I mean, what in human endeavors in history have not involved high cost not only in expenses, but in human life? Not that I advocate that, but I think that the human race is a pioneering species which is on its way. Ultimately, perhaps the stars, although that's more difficult than any but astronomers know, and that's many, many, many centuries downstream, should it happen at all. But to the rest of the solar system, especially the inner part, to some degree, an increasing degree as time goes on, I am very confident that's the case. Carl's at liberty to disagree, others may, but I'm stating my basic position. Okay, if the human race is moving out to space, how does one do it? The first step is to be able to get into orbit. Well, we learned how to do that, and then as Carl pointed out, we destroyed it. We actually wrecked the machinery, broke up the machinery that built the Saturn rockets, I think in 1974. It's an astonishing thing. But anyway, the Russians have it, and we are recovering it. So we have ways of getting into space. And even the shuttle, bad as it is in some ways, is not entirely a wrong-headed thing in my estimation. It's the first attempt to build a vehicle that can fly into orbit and fly back. Now, it's a primitive beginning. It's sort of not even a Ford tri-motor, but you have to start somewhere. And back in the 20s and the teens, we didn't have Boeing 747s either. The shuttle, I think, is an evolutionary development that I personally do not think the country need to regret, except that at the same time we threw away our auxiliary launch capability as well, which was the great mistake. All right, so we start out being able to get into orbit. What do we do next? We build a space station. Most of you know the Russians already have a very competent space station, and we're marching along behind. We will probably have one in 96 or 7. Then, where do you go next? Now, here is the crux of the question. Do we then decide that we shall make the leap to Mars, just like that, or shall we go next to the moon? I contend we should go to the moon next. Not that I disagree that Mars should be a goal immediately beyond that. I absolutely firmly believe Mars should be the subsequent goal, and it in turn, not only for its exciting science and history, but also as a further springboard for the human race ultimately to move out and develop resources of the solar system. I mentioned resources of the solar system. One very brief detour here. What are those resources? Fundamentally, there are three. There's effectively an infinite amount of energy there in the form of solar energy to be tapped in the free space environment. And there's more energy than I can describe. I've sometimes spent 20 or 30 minutes trying to get that one concept across to a class. The indescribable amount of energy that is pouring out from the sun, large amounts of which ultimately can be trapped and made use of. Energy is the ability to do work. If you can do the work, you can do almost anything else. There's virtually an infinite amount of material out there. Now, it's not always in easy forms to work with, but with energy you can work with it. And finally, there's an awful lot of space. And I think given those three things, energy, materials, and space, the development of the solar system will in fact continue, and the reason for having people out there supplemented, in fact heavily using robots, is precisely the development of space. Now, the moon is the next place to go, I contend, on that route. But is it only for future development? In fact, this point of development scarcely appeared at all in our discussions in the last 2 days. And it's, you might say, my idiosyncratic point of view, although one I believe in quite firmly. But I think also there are reasons intrinsic why we should go to the moon, which are in several categories that Dr. Mark spoke of earlier today, in fact. These include the fact that we really can learn a lot. It's not absolutely essential to use the moon as a way station to Mars, but I contend that in so doing, we will make the Martian expeditions a lot more feasible, successful, and probably not even delay them an enormous amount beyond trying to do it in one fell swoop. Also, if we wish to set up really continuous shuttling to Mars, which I think is the only thing that makes real sense, because you have to remember that if one talks of human exploration of Mars, these poor astronauts or Martianauts are going to land somewhere on Mars. Their job is to survive for a few months before they get in the spacecraft and get back. They're not going to be able to traverse hundreds or thousands of miles and explore all the wildly exotic terrain. They'll examine a local area, which already may be fairly well known, or the site wouldn't even been picked by robots for that landing. Ultimately, when human beings can truly, deeply explore Mars, it's going to be an immensely exciting place. But in the beginning, for a long time to come, it's going to be a spot check, and the science will be limited. But the point is, we'll do more Martian work. We'll have an infrastructure in place if we have the moon well developed, and if in particular, the moon, as seems now can surely be done, becomes the source of the primary fuel, oxygen, for the really large-scale interplanetary voyages of the future. Now, all of that's background. The foreground that I particularly come to it from, the point of view of an astronomer, is what can you do on the surface of the moon? The answer is science. A number of very interesting kinds of science we don't have time to go into. I'll mention just the one I'm especially driven by, astronomy. The moon is the place in the solar system from which to do most of the best astronomy of the future. Now, that's another long story. I've spent a whole hour at times talking this subject alone. No time to go into details. But briefly, the moon offers you an atmosphereless place which nevertheless is solid. You can put down very low-cost telescopes, large numbers of them. You operate them remotely from the Earth. If repair is needed, you have your little lunar base. People, in effect, wander out and make the repair. Immediate proximity to cryogens, power, repair, and so on. It turns out that astronomy from the moon should be a great deal less expensive if you don't require the astronomers to pay all the cost of setting up the lunar base. Now, that's quite an if, and it involves all these other things. But once the lunar base is going, astronomy should piggyback with great success with extraordinary developments, especially in terms of what we call interferometry, where we get not merely the present 1 or fraction of a second of arc resolution on the sky that we get from the ground, but 100th, 1,000th, even in time a millionth of a second of arc resolution on celestial objects. And telescopes of enormous size, great complexity, essentially free, low temperature conditions for thermal IR. One can go on with the virtues of the moon. It's a great place from which to do astronomy. Now, very finally, the moon also offers, as far as space is concerned, the leading place, I believe, for early international cooperation after we indeed get going on this absolutely essential mission to planet Earth. Because within reason, when we get the freighter lines going to the moon, and I do visualize them starting within 12 or 15 years, it will be possible for many nations, just as we do in Antarctica, to set up their own little base, but in collaboration with others. And I sincerely believe that we'll have an international observatory with a large number of astronomical instruments which are operated both individually by countries, much the way the European Southern Observatory has individual telescopes from Denmark or France or what have you, but all part of a complex and sharing with each other. Only this will be truly international, and we will cut our teeth there, and then we will make the trip to Mars successfully. Carl, I want to go too. All right.
Thank you for a very, I think, cogent and lucid presentation of the idea of the value of the moon. Roger, do you want to take over and bring us back to Earth, Western Europe, in fact?
Thank you, Boris. As the non-American participant in this workshop, together with other colleagues from Canada and from Germany and France, I would like to say that it was for us a great opportunity to participate in this workshop. And I would like to thank the Policy Institute and the Planetary Society for having invited us and participated in this debate. I was invited because I represented the European Space Agency, which is, as you may not know, but I say it again here, an agency which puts together the efforts in a coordinated way of 13 nations in Western Europe. And we have also Canada as an associate member. And as such, we cooperate with the United States and with Soviet Union also, but we also collaborate with other parts of the world, China and India. It is true also to say that there are other space agencies in Europe, in France, in Germany, in Italy, and in England. It would be dishonest not to say that very often, sometimes during this workshop, the Europeans and the non-Americans felt a little bit left aside in these discussions, which mostly focused on the dipole, Soviet Union, USA. And we had some delicate moments to find our place in this discussion. And in fact, it's true that it's not an easy matter, and it's true also, it's fair to say that dealing with a new partner who shows mood of openness, perestroika or glasnost are two words which are very popular these days, needs a learning period. And of course, this was a key element in our discussions. But it's true also to say that space exploration has ceased today to be the affairs of only a few countries or a few organizations, but is a worldwide activity and an essential motor of knowledge in science, but not only in science, also in politics and in international relationship. So the question is no longer today whether or with whom to cooperate, but rather how. And the example of Soviet Union was a good example during these discussions, because very few people did not know how to handle this situation. We also have to deal with making today lasting commitments in a world which is changing every day, if not every minute. The example again of Soviet Union is a clear example of that. 2 years ago, who would have guessed what happens today? And who knows what will happen in 2 years' time? So this evolution is an essential element to take into account when we deal with long-term commitments, which probably dictates that we have to work prudently, but not necessarily taking a negative approach to that. But USSR is not the only place where things are moving. 1992 will mark the 500th anniversary of the discovery of the America by the Europeans. But 1992 will be also a very important date in Europe. This will be the time when the borders between the largest number of nations in Western Europe will be opened, a real open market. And this is a changing element in the world scene. It has been said that it creates a new superpower. I hope it is the case. It will be at least a tripole. But we also see Japan coming up at the horizon. And this is also an essential element in the world scene. So these elements have to be taken into account when we deal with international cooperation on such big ventures as a mission to the moon, or even more, a mission to Mars. There are two ways to cooperate internationally. One which is simple and the most cost efficient probably, and also the most scientifically rewarding, but probably the less politically interesting, is the coordination of missions already existing in each nation or in each agencies, whereby you add a lot to the science you get out of these missions by putting them together in a coordinated way rather than taking the science of each individual one and adding them together individually. So as I said, this is a low-risk approach, scientifically rewarding, but not necessarily the best approach politically. The other one, which consists in defining a common goal and achieving this goal together, is, of course, the one that we are talking about when we discuss more the Mars mission or even the Moon mission. This is much more risky and needs new means of cooperation, new means of working, new methods. It's very difficult to accommodate this. For example, I remember in July this year, we had, thanks to the Planetary Society, and we organized with Planetary Society and ESA a workshop to assess how the Europeans could participate in the Mars mission. We found ourselves completely stuck in a discussion where the Europeans and the Americans on the one side said, well, you need to go into a phase A activity, and then you go into phase B and phase CD. And the Russians looked and opened their eyes, and they didn't understand what we were talking about. What is a phase A? What is phase B? What is phase CD? As they told us, we design our mission at the same time we think about it. And these two different approaches, long-term planning in a sense and real-time activity on the other side, are sometimes not easy to reconcile. But if we are serious about going together on these big missions and tightly coordinating or cooperating, requires that we learn the methods of each others. We have been, as I said, able to cooperate on both sides, with the Americans and with the Soviets in Europe. With the Soviets, I would like to recall that we coordinated our missions to Halley's Comet 2 years ago, and that was a beautiful success thanks to the international cooperation. The Soviets leading the way to Comet Halley and showing exactly where the comet was, so that the Europeans, following a few days later, could target very precisely the nucleus of the comet and shoot at it at 500 kilometers of missing distance. This was also possible thanks to the crucial help of the Deep Space Network of NASA. But we also cooperate extensively with the Americans in Europe. We have many missions that have been done in cooperation. The Ulysses mission, this mission which goes above the plane of the orbit of the Earth and will fly above the poles of the Sun. We participate in the Hubble Space Telescope, certainly as minor partners, but our participation is crucial to the fate of the Space Telescope, since we supply one focal plane instrument, a crucial one, and also the power system of the Space Telescope. But we also coordinate and cooperate in the field of solar terrestrial science. And we also just recently accepted in our program a participation into a new mission which is being discussed at this time in the United States, a mission to explore the rings of Saturn and to land a probe on Titan. The Europeans would land this probe on the atmosphere of Titan and land it on the surface of Titan. Incidentally, the name of this probe is called Huygens, from the name of the European astronomer who more than 300 years ago discovered Titan through the lenses of his telescope. In this changing environment where we see this new power arriving, coordination is necessary. We cannot do that randomly. As I said, we have to learn, and we have to find ways of knowing better our partners. In the mission to planet Earth, I think myself that there is here a great potential and a great necessity to coordinate our efforts for the benefit of mankind. We are really, and Carl has shown us the danger of not controlling what we are presently doing on our environment. Space offers a unique way to have the global view in order to control better this environment. But here, how can we think of such a cooperation without the major industrialized countries, which are the main outputs of all these hazardous elements in the atmosphere, the CFCs or the carbon dioxide? Here, I see a great necessity to improve on the ability to exchange data, especially between Soviet Union and the rest of the world, where they have a lot of data and where they need the data from the West. So this dual link is absolutely essential and is missing, but it's a delicate matter because it needs to transfer data from that part of the world to this other part of the world, and you need the networks or the necessary element to do that. For the moon, I think it is another dimension there. We are going to a place which we know already. We have explored it. We have landed on it. We have put man on it. We have brought samples of this soil, and we know how rich it is in certain elements. So the moon's mission is more or less an exploitation mission. We need to exploit the moon, scientifically speaking. It's a very challenging place to put astronomers, or telescopes at least. It's also a place where you can find enormous richness in the soil. So it's more like an exploitation base that we should think of. On the Mars mission, here I think we are in the realm of exploration still. It's not because we have landed the two Vikings, and that was a beautiful mission, and that the Russians will land a series of robots in 1994, that we should say that we know the planet. We don't know the planet. We have to go to many places on this planet, which is a very fascinating one. And here again, it is impossible, given the resources involved, that this is not done in a coordinated way. I think that my own experience, our own experience in Europe to cooperate with Soviet Union has been to go prudently, but in a positive gradient. And I think we are certainly encouraged by the very positive attitude of the present Soviet leaders in this approach. And during the workshop we discussed, and I certainly did strongly endorse this concept of making a small step in this direction to study jointly, just study, not spending a big amount of money, not exchanging hardware, but just study a mission to Mars together with the Soviets, the Japanese, the Europeans, or whoever wants to join. We have to find this approach. We, the Europeans, cooperate on the space station with the Americans, the Japanese, and the Canadians. We also cooperate with the Soviets. We have to accommodate this dual activities, this dipole. And I think it is essential that we get together the five main space agencies, the five main space powers together to work in the future. I will stop here, but I would like to make a suggestion to Carl Sagan. He had a problem to identify who would be the first one to put his foot on the planet Mars. And he suggested that we should fasten the ankles of the American and the Soviet commanders of the mission. First, you could take a bigger rope and maybe fasten the ankle of the European on board. And if you don't find the bigger rope, then ask the European to step down first. They have done that 500 years ago when they discovered a new world. They could do it again.
Thank you, Roger. The United States has much to learn from the experience of Europe becoming a federation of nations, and certainly in the space experience, there's a lot of directly applicable experience and ideas, and I hope that we're aggressive in pursuing it. Dr. John McLucas, our next speaker, is now coming to the podium and will provide yet a different perspective on international cooperation.
Well, we were told that we should talk about what came out of our meetings of the last 2 days. I suspect that most of us came out with the same biases we went in with, but perhaps reinforced to some extent. But I did learn some things. For example, I learned that Carl Sagan does not talk only about Mars. He used quite a large fraction of his time talking about mission to planet Earth. But I passed out at this meeting 2 articles that I had co-authored on exploration of Mars. And so none of us is following the prescribed scenario. I've gotten quite a bit of criticism from my friends who say, you're supposed to work mission to planet Earth. You're not supposed to work Mars. So I think it's just as well if we diversify a bit. In Carl's talk, he mentioned the practical aspects of space as well as the political and the visionary. And one of the most practical examples, of course, is communication satellites, and they're not only practical, but they're a big thing, and they've had a dramatic effect on the way we see the world, see ourselves, the way we communicate. And in fact, I think they've had very far-reaching consequences, political as well as otherwise. Some people say the military reconnaissance satellites are the most important outcome of space activity. I won't debate that, except to say that a few people see the results of the military reconnaissance satellites, and everyone has a television and therefore knows what the communication satellites do. Well, we all know that Arthur Clarke is a man who invented the geosynchronous satellite, which is used for communications, and we know that he also uses frequently the term a global village, although he's not the only one who uses it. Arthur has chosen to live in Sri Lanka, which is a paradise, at least by his definition. It has good scuba diving and a mild climate, and perhaps it was the only country available at the time who was willing to pass an act of Parliament to give him a tax break on all of the royalties he was earning in the United States. But in any case, he chose Sri Lanka, and he has become something of a hero over there. But Sri Lanka is a sad example of what can happen in paradise. I happen to be chairman of the Arthur Clarke Foundation, and one of my jobs is to pick the annual speaker who will give the Arthur Clarke Lecture in Sri Lanka. This year is the 25th anniversary of the communication satellite in synchronous orbit. It seemed a logical time to pick Harold Rosen, and he has written a speech which he should give next week in Sri Lanka, describing the invention of communication satellite in a practical sense. Arthur had done it on a theoretical basis. And I have a copy of his speech. Unfortunately, he will not be able to give it next week because the situation in Sri Lanka has deteriorated to the point where it's considered not a smart idea to go over there. And so I point this out for one simple reason. The communication satellite has brought people together all over the world. Continents are now in touch with each other which could not be in touch before. At the same time, it cannot solve the simple problem of a civil war created by ethnic differences in an island which is only 30 miles across. You would think you wouldn't have to go into space to solve that problem, and yet it's bigger than what the satellite has been able to do. Well, the reason I'm here talking, I think, is because I'm involved with some international activities, and the first one I will mention has already been mentioned by Joe Pelton, the International Space University. I think this is significant in two senses. This university was created by 3 young men in their 20s. They call themselves first the space generation. What does that mean? It means they were all born after we were engaged in space flight. As they looked around for practical things to do, it occurred to them that an international space university, which would bring people together from many countries, could play a key role in getting people to learn to work together. And that those people who plan the space missions of the future would have a total international perspective. So they persuaded some of us to act as their board and to help them sponsor this activity, and we just completed our first successful season. We had 104 students from 30 countries, convened at MIT, and everyone involved has pronounced the results a huge success. I see several of our board members in the audience, including our chairman, Ian Pike. The first year, as I say, was at MIT. Next year we'll go to Strasbourg. I think Carl also set the stage for this. Mr. Sharif showed that people who learn to cooperate and share joint experiences, we'll be able to do good things together. And now the next international activity I wanted to mention is the International Space Year. This, of course, is the year 1992. One of my daughters said when she heard I was working on the International Space Year, you know, there's an interesting coincidence. That's going to be the 500th anniversary of Columbus's voyage. I said, it's not a coincidence. Anyway, in 85, 86, the International Space Year legislation was put on the books. Congress, the President signed off. And a year later, we were able to conduct the first International Space Year Association conference in Hawaii under NASA sponsorship. And there we had nations from all around the Pacific plus Europe planning together on what could be done internationally with regard to space exploration. And we had 6 different workshops: space science, planetary exploration, space transportation, etc. But the one that I was most interested in was the remote sensing group, and I proposed there something called International Landsat. I thought that Landsat would be a much better project if it were operated on a basis comparable to Intelsat. Well, there was a Frenchman there named Pierre Bescon who said, well, that may be a good idea, but you can't jump from where we are today to an international Landsat. Why don't we form a remote sensing council, and one of its agenda items would be to look into whether international Landsat is a good idea. I thought that was a terrific suggestion, so when we held our second conference in New Hampshire in April of this year, I again talked about the Remote Sensing Council. Well, we had another good Frenchman there. Hubert Curien was chairman of this particular conference, and he convened a session with the various space agencies that were represented there. There were 17, by the way. And he came out at a coffee break, and he said, John, I'm having trouble selling the idea of a council. He said, we've got to come up with another term. Some people say council connotes too much authority. I said, I didn't realize it connoted any authority at all. He said, well, I'm having trouble with the term. What would you think of the term forum? And I said, it sounds like a wonderful term. So anyway, out of there came the SAFIC, Space Agency Forum for the International Space Year, and these 17 space agency representatives agreed that they would convene periodically and share their activities on remote sensing, or if you want to call it mission to planet Earth. And since that time, we've had 2 more meetings, and the number 17 has grown to 22. So I think that is moving along. By the way, one of the people at that meeting was Roald Sogdiyev, whom many of you know. And I frequently say that if Sogdiyev didn't exist, he'd have to be invented, because he's the precursor of Gorbachev. He was following his own model for years before Gorbachev saw him in action and decided, you know, there is a way to operate and to win brownie points by acting more like, you know, ordinary people. But when I saw Sogdiyev there in New Hampshire, he saw me, he rushed over and he threw his arms around me, and I was sort of taken aback. I mean, I don't have Russians grabbing onto me every day. And so I said, you know, if my Air Force friends see me here, they'll probably lose my clearance. Anyway, Sogdiyev is an interesting character, and he always has something interesting to say. For example, we had lunch with him here recently, and he said, it's not true that we don't have personal computers in the Soviet Union. He said, we have 50,000 and 1 printer. Anyway, at this particular meeting, his comment was, you're trying to find a term that doesn't connote too much authority? He said, I've just been made a member of the Politburo. Why don't you call it the Politburo? Well, I think if we're going to talk about space activities at a time of budget constraints, we have to show that space is a practical kind of activity. And that means we have to draw up certain priorities. At the same time, I think we have to recognize that one of the main reasons for being in space is political, because we started the Apollo program because of political reasons. I claim that one of the main reasons we're doing the space station on an international basis is political. And people talk about how you can save money by going international. I think that's probably true, although I think it's also true that it's much more difficult to operate an international management structure than it is one based only in one country. So I think there's many offsetting factors, but the political factor overrides, I think, any of the other difficulties of a management nature if you can pull it off successfully, because these people who are working together are going to develop common ties and reasons to cooperate more in the future. I'd like to think that, as Carl has said, that the political significance of cooperation that involves the Soviet Union would transcend what we've done with our friends in the International Space Station, and that there might come a time when we would think just as casually about cooperating with any nation on Earth as we do in cooperating with our friends in Canada, Europe, and Japan today. The last subject I wanted to mention was my role as chairman of the NASA Advisory Council. In that role, I get an opportunity to give NASA advice, which they may or may not want. But recently I went to a meeting of the International Astronautical Federation in India. And this is, let's face it, India is a third world country. The International Astronautical Federation typically meets in an advanced country, a country with high technology, with mature space programs and so forth. But India is the, you might say, the example of how a third world country can mount a space program which has very practical consequences. First, they had an experiment which NASA helped them do to show that communication satellites could be a good educational tool. Now they have INSATs in operation. Not only is it good for education, but it's a huge money maker. They've found that everybody wants to put ads on their television programs, and not only that, it stimulated a new television production industry over there. But anyway, that's not what I'm supposedly talking about. In the lead-off sessions of that conference, there were several speakers talking about different things. But one of them was Bill Ballhaus talking about space exploration. The other three talked about how space could be used for what I'll call down-to-earth problems. I see one of the speakers sitting there who talked about an audio broadcasting satellite that could take programs all around the world. But the three people talking about down-to-earth problems, which the third world needs space to help solve, it seemed to me sort of set the tone of that whole conference. So I came back, composed a letter to the NASA administrator and said, mission to planet Earth is the way we've got to go. On a priority basis, it's obvious that every third world country, every advanced country, all of us need what we can get by intensive exploration of the Earth's parameters, and this has to be our priority mission. About 6 months ago, I found myself talking to a second grade class because I had a grandson in the class, and I pulled out various models of spacecraft, airplanes, and various gimmicks. And the thing that surprised me about this exercise was they kept me there for 2 hours. But although they learned something from me, I learned a hell of a lot from them. I found that these 7-year-old kids knew 100 times as much about space as I did at the same age, and that they were ready. Anything you mentioned to them about what kind of activity you wanted to carry out, or any international cooperative venture you might imagine, they were ready to talk about. So I think we've got to get up in step with our own kids. And let me close on a small example of international cooperation. There's several of us in the room here who had something to do with putting together a 10th anniversary celebration of the Apollo-Soyuz event. Now, there was a political event, and it's a good example of how you can gain political mileage out of international cooperation. Many people thought the Apollo-Soyuz event was sort of a nothing happening. It was so small. What really happened? A handshake in space. And yet, when we brought together 600 people in the National Academy Auditorium to celebrate that event, you could feel the chemistry, the vibrations in that room. People saying, you know, this was a great thing. Why don't we do more of this? And I was reminded of some of the problems we had in pulling that off. For example, relations with the Soviets were very upset at the time of the 10th anniversary because of Poland, Afghanistan, and a lieutenant colonel had just been shot in Berlin and so forth. And when we called the NASA administrator and said, we'd like to put on this demonstration, this celebration of the 10th anniversary, and we'd like to have you participate, he said, I can't go near the place. And he recited all these problems that we were having with the Soviets. And he said, besides, if we tried to cooperate on that, the White House would be all over us. You guys don't understand the problem. Well, fortunately, I knew someone in the White House who used to work for me. He was a colonel. And so I called him and said, you know, I think a call from you to the White House, from the White House through you, is all that's needed to get the NASA administrator to cooperate with us. The colonel made the call. We had the celebration. And as I say, 600 people had a hell of a good time celebrating international cooperation. Now, I don't know which event leads to which next event. I think there's no way you'll ever know. But the Soviets were impressed with the fact that we were willing to take an initiative at a time when the relations were not ideal. And they sent people over, all the cosmonauts who'd participated in that event were there with us. People had their arms around each other. And the Alexei Leonov and Tom Stafford were on TV the next morning together. They had their arms around each other. And I remember Alexei's last words. He said, I would go anywhere with Tom. The advantage of international cooperation. I'll use my time.
John deserves some extra time because I neglected to mention he's been the chairman of our whole conference. And so he deserves a lot of credit for putting this together. Our last speaker, Dr. Evans from Canada, is going to give us the view from our close neighbor as I think both the view of the problem and perhaps the view of ourselves in that regard.
Well, thank you very much, Bruce. I'd like to echo Roger's sentiments that certainly I and the Canadian government are very pleased that we were invited to participate in this conference, and we extend our appreciation to the organizers for having us come down. We've heard a lot in the last day and a half and today in today's plenary session here about some very high ideals in terms of space cooperation and in terms of international cooperation. We have lots of ideas: mission to planet Earth, a return to the moon, and a voyage to Mars. What I'd like to do in a very quick wrap-up from my perspective is to try and bring us a bit down from some of these high ideals and explain, or at least talk a wee bit about some of the practical sides, the practical problems of, in fact, carrying off these very large international cooperative programs. And what I'm going to give you is the perspective from the small guy. Canada is a small guy in the space business. To put us in perspective, we're about 8th in the world in terms of our expenditures in space as a percentage of our GNP. But nonetheless, we do feel that we have contributed to our own national economic and social strength through the use of space, and also we believe that we've been able to contribute to various programs around the world. We do cooperate, as Roger mentioned, as a cooperative member of the European Space Agency. We have cooperative programs with Russia, with the United States, of course, Japan, Sweden, and many other countries. And what I'm going to give you is a perspective from somebody who has just come from the front lines of negotiating the space station agreements. I was a co-chairman of the Canadian side, responsible for our participation in the negotiation of the Intergovernmental Agreement and the Memorandum of Understanding. In my view, the space station agreements have forged a substantial new ground and have set a new baseline for international cooperation. I think we also have to appreciate how long it took to do that. I can remember the first visit of James Beggs to Canada with the invitation to participate in space station, and I believe that took place sometime in 1984. It was in 1988, near the end of 1988, that we eventually signed the international agreements. It was 4 years of intense discussion, negotiation between friends and allies. And what I would like to caution about is, or at least put on the open for people to think about, is when you start involving other nations with whom you have not had such extensive and long-term cooperation, how long will it take to negotiate the agreements for a trip to Mars? What did space station agreements do? They really set new ground in terms of political commitments. For the first time, we have a multilateral treaty between nations with respect to an international cooperative space venture. These international treaties have established the very difficult ground rules in terms of legal cooperation, the legal aspects of living and working in space together. These documents have addressed the very touchy issue of technology transfer. How can we have all these nations working together to build hardware which will exist together, and with foreign nationals from many nations working on the space station using each other's equipment? But primarily, I believe that what space station has done is forge a new way in which international programs will be managed. And to some very large extent, I believe that the way in which this program is implemented over the next several years, the success or failure that we collectively, the United States, Canada, Europe, and Japan, the success that we collectively have in actually making the space station management process work, I think will have a significant influence on the way in which future major international space programs are undertaken. There were several lessons that we had to learn as we went through the very arduous and sometimes difficult process of negotiating these agreements. One thing which is very clear is that the space agencies around the world are not in control of such major programs. It is the governments of the various countries that are in control. I go back a long time in the space program, and I remember negotiating agreements with NASA, with ESA, with Japan, on projects which involved just the space agencies of those countries. Those are very simple agreements to negotiate because the technical people have exactly one common desire, and that is to produce the best piece of hardware to meet a common set of objectives. When you move into the era of creating international treaties, you bring in a whole baggage of other concerns. And I think it's something that we all have to bear in mind, is that there has to be a very strong political government will behind these projects in order for them to work. Another thing which was alluded to today at lunch by James Beggs in his speech to those of us who were privileged enough to be there is a lesson, I think, that was also learned in this process. And that is that the United States no longer can claim to be the leader in everything in space. If we go back in the past 25 years, that was clearly the case. However, in my mind, there is a new order, and as a small player, I think I can say this, there is a new order in the international space arena. The European Space Agency has had more than 10 years experience in making 13 nations at the government level cooperate in international space programs. The European Space Agency is going to double its space budget in the next 3 years. Japan is an emerging space power with goals of having its own independent manned space capability. We're all aware of the progress and the prowess of Russia and China. And I believe that this new playing field, this more level playing field, is a fact of life which in the space station negotiations I think the United States had some difficulty realizing. The other important thing that we realized, that with this leveling of the playing field, with the oncoming of strong players internationally in the space business, technology transfer is a two-way street. That means that no longer is the U.S. concerned only about protecting its own technology and its transfer, that the rest of the world has similar concerns. And so there is now a new force, a new impetus, I believe, on the international scene to ensure that we share our technology towards a common purpose, and that we do so in a regime which meets the individual objectives of the various countries. I think the prospects for international cooperation are better as a result of the fact that we have the space station agreements in place. They are a forerunner of what will be necessary for a multilateral manned mission to Mars, or a multilateral exploration and revisit to the moon. However, I believe that space station is a turning point in terms of these international treaties and management setups and organizations, and that as we go forward, we'll find that there will be more equal partnerships, and that we will find that in some instances, the United States will take the lead. In other instances, other nations will take the lead. I also believe, as we listen to I guess what I took away from this conference is, and I apply my space station experience to the concept of moon missions and Mars missions, that the time is now to start to plan and work with all the international partners towards a common goal. It takes a long time to put these in place, and if it takes 4 or 5 years for friends and allies who have had a long history of cooperation to put an agreement of this nature in place, it's going to take much longer to bring in the rest of the world's countries. Thank you.
Well, thank you very much for some very fitting words. I think we do have some time for questions. What I'd suggest, Carl, we got an extra seat. Why don't you come on up and provide a target here. And I guess the best way is for people who have questions simply to approach one of the microphones. I'll try to recognize you and, if necessary, repeat the question. Go ahead. No, speak a little louder.
I don't believe that there's a great deal of skepticism that given enough money and the desire to do so, that we can technologically stage a mission to Mars. One of the concerns that was expressed at a recent conference of the American Astronautical Society is how fit is man physiologically and psychologically to undertake a mission that will last anywhere from 18 months to 3 years, depending on how it's staged. That is going to take a long time to develop and demonstrate the human technology to coexist and to exist in a small environment for a long period of time. An example that was made is that when the Russians come back from their very extended missions in in Earth orbit, that they need physical assistance when they depart the spacecraft because of the condition of their physical state. Who's going to help the Mars visitors?
We'll let Carl respond to that.
Well, there's no question that the physiological issues have to be addressed. I remind you, however, that Soviets have already been in Earth orbit for longer than some of the trip times to Mars. I spoke to one of the Soviet cosmonauts who had been up for many months, and he said when he landed he was able to walk 1,000 steps along the center line on a highway. Sort of an interesting image of him emerging from the spacecraft and doing this drunk driving test. And so he was a physician. So it was his contention that this is not a serious problem. If it is a serious problem, then the alternative is to spin the spacecraft up so you get through the centrifugal pseudo force 1G or 0.38 G or whatever you want to do. But there's no question that you would not commit people to such a mission without a great deal of experience in a simulated Mars flight, and that's one of the many things that has to be done. That's why it takes time to do the preparation, but there is no hint of insuperable physiological difficulties.
Let me just add to that we've talked a lot about the goal, the long-term goal of human flight to Mars, or the moon, but especially Mars, and discussing the political benefits and so forth. What we haven't talked about, and I think it tends to corrupt the conversation a bit, is that that's not what people would be doing now. Nobody's going to run in the wildest scenario and ask for a budget to go to Mars. What would from now to the end of the century, realistically, by any nation, is you've got to solve at least 3 critical problems, which can be solved within current budgets and current technologies and current programs, provided they're focused. One of them is you have to know more about Mars. That's robotic. That's fairly straightforward. Secondly, you need to know more about humans. That was a question mentioned here, both physiologically, psychologically, a lot of subtle things. You do that through space flight as well, but very carefully done. And thirdly, you have to know about reliable closed ecosystems, which is another thing. These spacecraft have got a lot of recycling in them. They've got to work for years, and it's a new technology. Those all can be done nationally, or they make very nice candidates for binational or multinational programs. They don't cost very much, and they enable the human species to go sometime in the next century to Mars. They also provide the critical political information as to whether these countries are really going to be able to work together. And you do it within technically manageable and financially manageable chunks. And so I want to be sure that's clear, that I don't think anybody's advocating making a decision to go now or to commit the kinds of funds that are required, but simply to pick it as a goal and then do the enabling things for the next decade. Well, I've used the chairman's prerogative on this. Do you want to add to it, Harlan?
Just make one additional comment. Anyone who's read the stories of the Napoleonic Wars period, for example, knows of the incredible conditions that men were crowded under decks in ships that sometimes took the better part of a year to go from anywhere to anywhere. Now, admittedly, they used the lash to keep them in shape, and maybe we should worry about that for the space program of the future. But no, seriously, human beings are immensely adaptable under difficult conditions, and these will be very selected people under highly stimulating conditions with all the resources a human race can bring to bear. I have no doubt, I agree with Carl, that the voyages in that sense can be made. There are other hazards.
When you begin to speak, if you wish, you might identify yourself.
Thank you, Dr. Murray. My name is Les Dorr. I'm with Final Frontier magazine. I wonder if you could address a point which I believe Dr. Evans touched on briefly. Something on the scale of an international mission to Mars is a decades-long undertaking costing billions and billions of dollars. And I wonder if you gentlemen have any thought on how an endeavor of that sort can be insulated against change in the political winds. Right now, of course, we have the movement toward perestroika and toward glasnost in the Soviet Union, but there's no guarantees that that's going to continue for an indefinite period. And in the United States, there's no guarantees that a future American president will continue to support the outlays needed for such an endeavor. So is there any way to insulate a joint mission to Mars, an international mission to Mars, against those changes in the political winds?
Who wants to answer? Carl again.
Well, I think it's a question of cause and effect. I think, at least my reason for supporting such a goal is in order to help produce a political climate in which the two nations have this shared common purpose and do not have uncomfortable changes of the sort you mentioned. So I don't think it's a question of first we magically produce a global situation in which neither nation has any chance of defecting from the cooperative relationship, and then we establish the joint mission. I think instead we establish the joint mission in part to accomplish that improved relationship between the two countries. And of course, there's some risk of failure, but the stakes are so high. I mean, I remind you that the cost for each side of this mission is roughly the same as a single strategic weapons system, and we have plenty of those. It seems to me worth doing, considering the importance of the issues at stake, quite apart from the adventure and science of Mars exploration.
The other aspect of this, which for this audience ought to be emphasized, that in a program of this type, you would segment it in time. That's what I'm referring to. There are near-term milestones, like 10 years, but nevertheless, that's the enabling technologies. And then if those milestones are met, one is prepared as a later decision to make the commitment to go ahead and go. So you segment it in time, and you also segment it functionally. And we've looked at, there's been a lot of study of Mars rover sample return by a group, a NASA-sponsored group of this, and a lot of attention has been given to how you do that. And it turns out that if that's a criterion of the structure of the program, that's rather straightforward. And so the idea of developing functionally separate and compatible synergistic units, but that have standalone capability if one of them fails or doesn't go. So there, you can design, I think a lot can be done in program design and in system design if it's understood that's a requirement. And that's part of our learning process in this new world. We ain't going to be the dominant one that does the system design, sets the program goals, and then invites our secondary allies, so to speak, to come join us. I think that was the message that derives from the talk we've heard from our foreign participants here, is that when we're no longer the big gun, even with the Soviets, if it's egalitarian with the Soviets or multinational involving ESA and the Soviets and other countries, then we're going to have to design programs differently. And I think that's possible, but we've got to change our mindset to do it.
Just one point that I was trying to make is that Space Station is a very large program, a very large multinational program. You have to realize that Space Station, in essence, changed the direction of very significantly, the direction of the program, certainly in Canada, in Europe, and Japan. They've all focused on Space Station as a primary objective. This led those international partners, Canada, Europe, and Japan, to think in terms of an international treaty as a way of buffeting the program from the whims of annual budgetary processes. And so we have tried that approach in the Space Station program to try and use that to buffer us from those problems.
Thank you. You want to take the phone and identify yourself?
My name is Ron Griffin with the Vitro Corporation. The question I have is, can someone briefly describe the major advantages of deploying telescopes on the moon for exploring the universe as opposed to just putting them in space like the HST?
Just a couple minutes.
Thank you. Yes, I'd like to speak to that. When you put a telescope in free orbit, you can do it. If it's in near-Earth orbit, you get into all kinds of complications. Let me mention a couple. First of all, you're whizzing around in only 90 minutes. You're moving at 8 kilometers a second with respect to the atmosphere. You're encountering ionized oxygen at a ferocious rate. The Earth fills half of your field of view. You can get a dark sky exposure for maybe 40 minutes at a time. It takes an hour or two to move the telescope from one orientation to another in extreme motion, somewhat less for closer ones. You have to balance the thing to the order of 1,000th of a second of arc against gimbals. Incredibly difficult, expensive. This is the reason why Space Telescope costs $1.5 billion, even though it's smaller than my relatively modest 107-inch telescope at McDonald. Now, that's tough. We could put much bigger telescopes on the moon for much less money if we only had to pay the transportation costs to the moon and had light-weighted units there. That's one level of argument. They really will be cheaper, provided the cost of building the lunar base is amortized against the human move into space and is not charged against astronomy. And I agree, the astronomy budget couldn't carry it. Now, that's only the most obvious example. Let me mention another. You'd like to do what we call interferometry in space in order to get high angular resolution. In principle, you can do that by putting remotely floating vehicles in space, and probably some of those problems are soluble, but it's all going to be expensive to maintain baselines, orientations, constant aiming of the telescopes at the sources you want to study, and so on. In principle, it can be done, but staggeringly expensive. On the moon, if you have the lunar base, you go out and plunk down your little telescopes. I'll mention just one more and then I'll subside, but again, this is a long story. I have several long articles on this. Let me mention one more. If you wish to explore new domains of frequency that have never been studied before, you normally find exciting new astronomical results. There is a domain from roughly a few hundred kilohertz in frequency up to about 10 megahertz that is essentially totally unknown. It's the biggest spectral window we know essentially nothing about. It would be almost impossible to build an effective system to observe this in space, and you can't do it from the ground because the Earth's ionosphere blocks it. On the surface of the moon, it would suffice to lay out little elements, really about the size of a pencil, at intervals of hundreds of meters, each of which has a little chip, solar battery, a little transmitter to send signals to a common computer. For an incredibly low cost, you build an array of tens of kilometers in size on the moon and get an extraordinarily effective radio telescope of a kind that could be built nowhere else in the universe. These are just a very few points.
Again, a lucid answer, and I can assure you there's a lot more where that came from. So what I'd like to do, because of our time situation, is acknowledge that two questioners are at the microphone, and that's where we're going to cut off, and hope that the panelists' responses can be fairly brief, too.
And my question is there any ongoing programs or even exploratory meetings on an international scale or even national scale? And if there isn't, the feasibility of exploring new means of propulsion in space beyond chemical propulsion so we can take up greater masses at greater efficiency and get greater distances in quicker time.
Who volunteers? Harlan, do you want to take?
I think that's yours. You're a JPL man.
Well, not recently. As far as I know, we did a little bit of work, or there was a little bit of agitation on this back in about 1980, and it turned up matter, antimatter, and it turned up exotic sails with giant lasers and so forth. And those were the two things. The outcome of those have been the giant sails became the basis of a science fiction novel by Bob Forward and technical papers with Freeman Dyson. And the antimatter is something that you watch because they take one antimatter particle at a time in CERN and they try to keep it in a magnetic bottle and they put another one in and then they put another one. And if you want to extrapolate in that way, it's a long way in the future. The answer is that there, as far as I know, there is nothing in the time scale we're talking about, including going to Mars, and by the way, I include any kind of nuclear rockets in that regard, that competes with existing chemical systems. And there's certainly no constituency to develop them. Beyond that, you know, science goes on, technology goes on. It's hard to know at what point some, radical change might take place. But there's certainly nothing that one can foresee or that I foresee in that time scale.
Specifically, one area I was interested in was evidently new material processing developments has allowed the thinking of solar electric propulsion and ion generation. Just in the last couple of years, Ted Taylor, who was behind the Orion project, is very enthusiastic about this potential.
I think the problem is that you can't show that the mission they propose to do, you can also do chemically. The chemicals exist, and that therefore there's not an incentive to launch a large development program. Let me give our last, I'm sorry, we got to sign off the last speaker here. Go ahead.
The name's Kevin Owens. I'm just a member of the Planetary Society. And one of the issues that has me puzzled is we've discussed a lot about international cooperation and the cost, the engineering, and the systems to get to Mars and the Moon. But there's little discussion of after we've gone there and come back is what do we do next? Is there been thinking about homesteading these places, or we find out what's there and then just do like we did with the Moon and say, well, we found out what there was to find out?
I think the easiest answer is the National Commission in Space report, which is widely available, deals with that hope and aspiration and also some of the difficulties in rather great extent. And beyond there, it's kind of voting your conscience about the future. I think but I think that report really is the best response to that. So with that in mind, I'd like to turn the meeting back to the chairman here and let you take over here.
Thank you, Bruce. Thank you, rest of the panel. God, we're right on schedule. It's remarkable. We're done, I think. It's been I hope you found a useful afternoon. I think the retention of a significant portion of the audience suggests that you found in our public discussions the same kind of intellectual excitement and challenge that we've been finding for the past day and a half. I thank you all. And who knows when the next one of these things will happen here at the university, but you'll certainly know about it. Thank you.
You've been watching a conference on space exploration, sponsored by George Washington University. Be sure to join us later tonight for a live viewer call-in program on the recent Soviet troop reduction proposals with Ambassador Edward Rowney. Coming up at 6:30 p.m. Eastern Time, 3:30 p.m. Pacific, live on C-SPAN. And coming up in a moment, a look at the congressional budget process with Rudolph Penner of the Urban Institute.